All right, well, we talked about erosion in the previous set of slides. So let's talk a little bit about deposition and what happens to that sediment once we have it. The beach is what's made up of those loose particles. So the wave action is going to move the particles back and forth. Swash carries the particles onshore. Backwash carries them offshore. This is a lovely diagram in your book. It's a typical beach profile. If we had the exam in class, I would actually have you draw this, so I'm not going to make you do that on the take-home version. But there are some important features to notice on here. So we have the beach, and if you ever go to the beach, or in the future, I suppose when you go to the beach, when they open them back up, one of the things after having taken this class you might notice is some of the features that we find on a beach. Because of the way that the waves move material around, we typically get something called a beach scarp, and very often we'll have a couple of beach scarps. They can be associated with high and low tide. A big storm can make larger waves, and that can give you a different beach scarp. And the little humps of sand that we find as we move toward the shoreline are called berms. And the front of each berm is called a beach scarp. If we go offshore, it turns out the waves can actually pile up sand offshore in a feature that we call longshore bars. If you ever walk into the water away from the beach, as you expect, the water gets deeper and deeper. But on a typical beach, if you get far enough out, you will actually hit one of the longshore bars, and you'll find that the water gets shallower for a little while before it gets deeper again in one of those troughs that you find between the bars. So a longshore bar is kind of an offshore sediment storage location, and a lot of beaches will have at least one longshore bar, but often they'll have two, sometimes even three or more. But most people will typically find at least the first one and go out there and stand and enjoy the waves, and kind of wonder why the water isn't as deep as it is closer to the shore. So that's the longshore bar. Now, it turns out that waves are going to be moving sediment along the beach. So a beach is not a static feature. The sand that you see on the beach today is not the same sand that will be on the beach tomorrow. And what's happening is the waves come in at a little bit of an angle. Most coastlines, they'll usually approach from the same direction on most days. And because they come in at an angle, as they push the sand along, instead of it going straight up the beach, it goes up the beach at a bit of an angle. And then when the water comes back out, as the gravity pulls it out, the water usually goes straight back down. And so the sand is transported in this zigzag pattern that we refer to as longshore drift. You can see the effect of this in the picture on the right-hand side. Longshore drift is going toward the top of the photo. You'll notice that they have built walls out into the water. Those walls are called groins. And the sand is building up on one side of the wall because the longshore drift is pushing it up to that wall, and then it can't get around. You'll notice at the very top of the photo, all of a sudden the coastline goes off to the right. It cuts way back. Where they stopped building those walls, the longshore drift has been carrying the sand away, and because new sand is blocked from replacing the old sand, that very top section of the photo shows some pretty severe erosion of the coastline. Now, if we put our erosion and our deposition together, this is something that we can see happening, which is wave refraction. And this goes back to a couple chapters to our chapter on waves. Remember, as waves approach the shore, one side of the wave slows down, and that will cause the wave to turn. And you'll notice that turning of the waves causes them to focus on anything that sticks out into the water. So what we would refer to as a headland gets this focused erosion. And then you'll notice that the part of the coast that's kind of inset a little bit gets a nice quiet beach, because the waves get more spread out. Longshore drift, you can see the black arrows there, will tend to move the sand from the headlands back into the beach. And over time, if this coastline is left alone, it will gradually straighten out. So on this picture, you can kind of see several things working together that we've talked about. The focused erosion, the transportation, and then the resulting deposition in that quiet beach. So if we look at the coastline in a larger sense, what you'll see is that the longshore current or the longshore drift will carry sand along the shoreline and create a number of features. One of the notable features you'll see on the left-hand side of this drawing is something called a spit. A spit occurs across a bay mouth. The longshore drift is bringing in the sand from the left-hand side. You can see that red arrow there. And when the sand gets to the opening of the bay, it just gets deposited in the bay mouth, and slowly that spit grows across the bay mouth. And so when we see spits along the shoreline, they point in the direction of longshore drift. You'll notice in the middle of this drawing, in some cases, the spit can actually completely cut across the mouth of a bay. In that case, we call it a bay mouth bar. But this is where we bring in the tide. The tide at high tide wants to fill in that bay with water, and at low tide, all the water wants to leave the bay. That movement of water in and out of the bay at high and low tide will typically keep an inlet open. And so you'll see in the middle of the drawing, they have a bay mouth bar, but it also has an inlet. So that's one of the primary effects of the tides, is to keep inlets open, because the water moving in and out of that bay will be fast enough to keep that inlet from closing. A feature that you might have noticed on this drawing is something called a barrier island. And this is what a barrier island actually looks like. These are two barrier islands on the east coast of the United States. One is Assateague Island and Fenwick Island. It's along the Maryland and Delaware coast. And Ocean City, Maryland sits right on a barrier island. Longshore drift, in that case, you can see the black lines represent concrete barriers that have been built to keep the inlet open and in the same place. Longshore drift would tend to move that inlet. But in this case, when they blocked longshore drift, Assateague Island got robbed of its sand, and you can see it's actually moving back toward the shoreline. The red line shows where Assateague Island was 150 years ago. On the lower right, we can see the Outer Banks of North Carolina. The green on the drawing represents the island, which is, you'll notice, very thin. And what that means is when a storm comes in, the storm surge and the wave erosion can actually completely wipe out a section of one of these barrier islands. And in this case, it created a new inlet, which the state of North Carolina did not want to stay there because it damaged the road and the utilities, and so they actually went back in and filled that inlet back in. But the natural process would potentially keep that inlet opened as the tide came in and out. Now, what happens to the sediment after it's on the beach? Well, if you remember back way before the first exam, we talked about something called turbidity currents. We talked about them a little bit more when we talked about the movement of sediment onto the deep ocean floor to the abyssal plain. And here we bring turbidity currents back again. This is muddy water that is more dense than the surrounding clean water, and it allows sediment to move offshore and basically be taken out of the system. So when we put all this information together, we get a feature called a coastal cell. This is one of the questions on your exam. Coastal cell is just combining all the information that we've talked about in the first slide presentation and this slide presentation so far. We get sediment from rivers and from erosion by the waves. The longshore drift then transports it along the shoreline, perhaps along the beach, and then sediment moves out of the system. In some cases, and here we go to the weather chapter, the sea breeze can pick sand off the beach and push it to inland dunes. That takes it out of the system. And you'll also notice on the diagram here toward the bottom, you can see the turbidity currents moving the sediment away from the shoreline as well. And in this case, it's out into deeper water. So we put all those things together and we get what we call the coastal cell, which shows you the big picture of sediment moving around on the coast. That just leaves a few other little interesting details. We did not discuss biological activity in coral reefs, and so that's what this slide presentation shows you. In some areas, life can kind of take over the depositional process. We talked about that when we talked about marine sediments. You'll remember we had the land-based sediments, the terrigenous sediments. That would be the sand and things you see along the beach. Here are the biogenous sediments. Under the right conditions, so if the water is clear enough and the area is not dominated by one of those land-based processes like rivers or a volcano or something, then life can move in and create a reef, which is essentially a pile, usually of calcium carbonate shells. Modern reefs are mostly coral. If we look in the fossil record, we find that throughout the Earth's history, there have been a number of different organisms, mostly making their shells out of calcite or calcium carbonate, that have made a variety of different types of reefs in the ocean. And basically, they create their own coastline if they're active enough to rise above sea level. We also want to mention estuaries, and one of the reasons why we mention estuaries is because they come up in the material for our next exam. This is a kind of an interesting place for life because of the differences in salinity of the water. We have a mixing of salty and fresh water that's dependent on how quickly rivers are adding fresh water and how quickly coastal currents and tides are bringing salt water into the system. So that's kind of your first mention of an estuary. We'll talk a little more about those when we talk about life in the ocean. With respect to U.S. coasts, if you want to see some of these things we've talked about on a coastline, if you go to the west coast, the Pacific coast, it's tectonically active. We mentioned that earlier. Most of the California coast is actually rising up above sea level. If you go to the Washington and Oregon coastline, we actually see evidence of fluctuation depending on plate tectonics. The coast will sink down a little bit, and then after a significant tectonic earthquake, it will rise up and then start sinking down again. So it kind of bounces up and down over periods of like about 100 years. And that's about all the time we have. You can read the stuff about Atlantic coasts on your own. And our last slide is about measures taken to slow beach erosion